Hi everyone, my name is Loic. I come from a startup called Constant Commerce. We do Node.js, Angular, vanilla JavaScript even, so if you'd like to know how we use those tags, just give me a shout after the talk. Tonight's topic, event-driven architecture. So if you've been to the Node.js website, the first thing you're going to see is event-driven non-blocking I/O. But what does it mean? To me, it sounds like black magic. And I have a trick given by Uncle Bob, for those who know him. The trick is, whenever you see black magic, just re-implement it yourself, and then once you've implemented it, it's going to let the magic go, right? So in his blog post, sorry, yeah. In his blog post, he takes the HTTP server as an example, and we are going to take him quite literally here. So tonight, we're going to implement a HTTP server, a simple one, don't worry. And then the next step is to create an event loop to integrate them both, and that's going to be 80% of the work. Then the 20% left, we're going to speed up a bit through it, but it's basically scheduling, promises, and threading. Right. So let's start. Okay, this is the story of input-output, also known as I/O. So what is I/O? I/O is communication between a client and a server. So for example, a HTTP client, like your browser, and your HTTP server, like Nginx or Node. So let's implement it. So can you see the code here? Can you read it well? Okay, so we're just going to go through the code line by line. It's not JavaScript because it wouldn't fit in the slides. So it's pseudocode, right? So the first thing you do when you create a web server is to create a socket. It involves 3 system calls, which are create a new socket, bind it to a host and port, and then start to listen on it, right? When you start to listen, you can accept clients, so clients can connect to you. But the issue is that there's a limit. It's a limited queue, and when you reach the max number of clients in this queue, you get errors. So the game here is to just treat clients as fast as possible to avoid the queue from being full, right? So to do that, you just start an infinite loop, and in it you accept new clients. So when you call this system call accept, it's going to take the first client in the queue and treat it. So you get a specific HTTP connection, a specific socket connection for this client, and that unqueues it. So it allows you to avoid errors, right? So with this client, you can wait for data to be received. That's the request. By the way, side notes, I/O is very slow. So you have many types of I/O. Has a table. Basically, it says that processor is very fast, access to memory is a bit slower, and then access to the hard drive is much slower, and the slowest one of all is network. And that's what we're treating here with HTTP server. And the issue with that is that if you're very slow to treat your client, your queue is getting full, and then you get errors. So the game here, again, is to get to enqueue as quickly as possible. So you get data from the client, you pass it as a request, you give it to your application, HTTP application, which creates a response. And then again, you write this response to the client socket, so the client receives something, and then you can close the connection. The issue is that I/O not only is really slow, but it's unreliable. Well, network anyway, because the client could have disconnected in the meantime. I mean, Wi-Fi, it never works. So again, we have a lot of risk to get errors while we treat a client, and our queue is getting fuller again, and we get errors if it gets full. So once we treated the client, we can close the connection and treat the next one. So that's a HTTP server, right? So basically, it's just a queuing system. And what we've done here is a basic HTTP server, and it's not very efficient. It can handle 100 connections in the same time, but more than that, it's going to get this queue full of clients, and it's going to get errors everywhere. So how do we handle more clients? It's known as the C10K problem. It's been around for a while, and thankfully we have a solution for that. Hang on. The solution is poll. So poll is basically, it's a system call that allows you to give it a list of sockets, and it's going to wait until one of those sockets is ready to talk to you. So when a client is ready to talk to you, it's going to return that client, and you can treat it. So have you seen what I did here? Hang on. Poll is hanging on. No, okay. Never mind. So there's actually many implementations of poll. There are 2 POSIX implementations, select and poll. There are epoll from Linux, kqueue from BSD, IOCP from Windows. But we're not going to dive into those details. We're just going to call them poll simply. Right. So what does a HTTP server looks like with poll? So let's have a look. Again, we create a new socket, just like before, except this time we put it in a collection of sockets. And once we have a collection of sockets, so the first socket is our HTTP server. So we start it, we put it in the collection. Then we start our infinite loop, and we give it to poll. So it's going to wait on this HTTP server socket, and it's going to block until there's a client available for you. Once a client is available, we get to the first if. So there's a HTTP connection for you. We're going to accept it. It's going to give us a specific socket for the client. And this socket, we're going to add it to the collection and then start to loop again, right? So we get back to the poll blocking, and it's going to block until either we have a new client ready to talk to us, or the first client is ready to talk to us. And in this case, for example, if the client is ready to talk to us, then we get the data, we pass it as a request, give it to the application, get a response, write the response to the client, then close the connection and remove it from the collection of sockets. So that's it. That's a loop, and those connections are events. So what we've just done now is an event loop. So we're just going to refactor it a bit. So basically, we're going to extract the event loop into its own class. So first method of this class is going to be run. So you run the event loop. It's where you have the infinite loop. You have the call to poll. It gets connection. And then for each connection ready, we call a callback. We have a callback. So it allows us to decouple the codes between the server and the client. We have a server callback. So whenever we have a new client ready to connect to the server, we have a callback for this. And then we have also a callback when a client is ready to send the request. So here's a usage example. So I think this code might be familiar to you. It's basically nodes, right? You create a socket, create an event loop. You append a callback to the HTTP server sockets, and then you start to loop. And so the first callback for the server is there to accept new clients. When it gets a new client, it registers the sockets in the event loop with a callback to handle clients. And the callback to handle clients is just calling your HTTP application. So get the request from the client, pass it to the application, get a response, etc. So that's it. That's event loop for you and HTTP server. With this, we have an efficient queue system. So usually the queue is quite empty thanks to this. So we don't have any errors. And that's been done using epoll, which is blocking, basically. So if you want to memorize something from this, it's blocking. If it's not solving all your issues, then you're not using enough of it. Because before, our issues was okay, when I accept a client, I'm blocking, and then I get my queue full. Now with event loop, you're blocking until someone's ready. So you block more, but it's more efficient. So that's the 80%. That's how Node works. You have an event loop, you get more clients, and it gets the queue empty. There are a few things that event loops cannot cover, so that's what we're going to see here. So when you don't have any clients, you have that poll call that is blocking and doing nothing. And so it would be great if we could do something while there's nothing to do, like, for example, debugging, monitoring, reports, anything. Wait a second, I've got something for you. Poll actually has a second parameter. It's called timeout. So you can tell Poll, okay, can you block until 10 seconds? And if you don't have anything, return. I can do something, and then I call you back for, again, 10 seconds. And that way I can do things while we don't have any clients. Did you see what I did here this time? Yeah, okay, good. So, nice. Okay, so this is called a scheduler. We have many types of scheduler in nodes. We have a one-off scheduler, so you can program a task to do something if there's nothing to do, just one time, or you have periodic schedulers. So every now and then, just call this callback when there's nothing to do, etc., etc. I'm actually not going to talk too much about this one. So it's a one-off scheduler. So basically what it does is you have a class where you can register callbacks, right? So you say, okay, you have an interval, say 10 seconds. You have a callback, just call this one, and then the arguments that you can forward. The other method is tick. So that's basically going to wait for the interval, so 10 seconds, for example, and it's going to then check if there's something to execute here. And if we want to integrate the scheduler in the event loop, it's quite easy. So in our run method, when we do the infinite loop, before calling poll, we're going to check what's the lowest timeout in our scheduler, and we're going to give it to poll, and then we're going to loop, and at the end of the loop, we're going to tick the scheduler. Again, it's to make your event loop more efficient, so you can do stuff while it's waiting. So it's using waiting time. So again, we had a lot of waiting, and now we're waiting even more, and we can do more stuff thanks to that. So waiting, if it's not solving your issues, then you're not using enough of it. Right. There's an issue with all those callbacks, with the scheduler, the event loop, the server. It's that we can get a callback hell, basically, because all those callbacks can be nested. It's not easy to write. It's not easy to read. If only it could feel more like synchronous code. So I guess you have heard about it before. It's called promise. Okay. I think this time you saw what I did here. But I promise that's the last time I make a pun. So yeah, future of promises. There are many implementations, but the basic idea behind this is that you have an asynchronous call that's going to call a deferrer that creates a promise. We return the promise, and you, the user, can use this promise to register callbacks when the asynchronous call is ready, right? it's actually quite hard to understand, but the code is quite short. So let's have a quick look about it. So again, we have a deferrer class that we use in our asynchronous calls. What we do is we call promise on it, and it's going to create a new promise. But what it does when it does that is it injects one of its own methods in the promise. This method is a setter. So let's see what it's used for. So then the asynchronous call is going to return the promise, so you can interact with it. You call then on it, and when you call then, you give a git callback, right? So the callback is, well, when you're finished, just call this, please. And so what it does, what the promise does, is it's going to call the method from the deferrer and forward it the callback, and that's it. And optionally return a new promise. And so the deferrer in your asynchronous call, when it decides that, oh yeah, so that's the setter, by the way. It just gets the callback and put it in a collection of callback. And so once it's ready, you just have to call resolve with value, for example, and it's going to call all the callbacks and forward the value to it. So that's how the value from the asynchronous call gets to your promise in your parent code. So that's it. Basically, to get rid of this callback hell, we're just chaining calls, right? So you can do promise, then. So again, we had many callbacks, and now we have even more callbacks, but that solved our issues. So callbacks, if it's not solving your issues, then you're just not using enough of it. Actually, promise and deferrer are quite hard to understand, so I think the best thing to do is to just show a usage example, right? Here's file system. I present to you file system -o. It's a subtype of IO, right? It's -o because it's the slowest of all IOs, basically. So the main issue about file system is that you can use it as IO, just like our requests and responses. But the thing is, when you pass it to poll is not going to block until it's ready. It's going to return it immediately. So you get the impression that the file system is ready to be written on it or read on it, but it's not. So basically, it becomes useless. So the solution for it, and that's what Node is using, is a thread pool. So don't worry, your Node.js application are still single-threaded, right? It's just that it's using a library, external library, where there is a thread pool in it. So it's quite separate from your application, and you don't get all the threaded complex stuff. So how does it work? Well, it's quite simple. It's wrapping all the file system calls into its own calls. So for example, to open a file, what it does is it provides you with an open call, right? So you give it the file name, and you give it a callback to call once the file is opened. And so what it does is it puts the open file system call, the actual one, in a thread pool, forwards the arguments. This thread pool is going to give you a promise. So on this promise, you can call then. Once this file is ready, just call my callback. And so that's it. So Node.js, in order to use this in the event loop and integrate everything, uses a scheduler. So that's why we saw a scheduler before. So if you have a look here at the last line, so what we do is we don't directly promise then the given callback. We give our own callback, which is on file open. And so what it does is it's going to say to Node, hey, in your event loop, the next time you have nothing to do, please call this callback, which is once the file is open, do something. And that's it. So basically, your event loop in Node.js is going to first check, okay, do I have any HTTP clients connecting to me? No. Do I have any current clients talking to me? No. Okay, so I just go out and check if there's any file system things to do. That's it. So yeah, that's it. So file systems are handled just by wrapping them in threads to make them act just like non-blocking I/O. So that's it. Threading, if it's not solving your problems, right? Actually, no. So it was a trap. So there's a thing about threading is that it's very complex and it has actually limits. So if you take a look at the file system example and you say, okay, I want as many threads as possible, like infinite pool of threads, you're going to get errors. Why is that? Because your kernel sets a limit of concurrent call to your file system. Usually it's 4. But the good news is you can actually change this limit. You can just remove it and get an infinite number of concurrent file system calls. That's great. But when you do that, it turns out your hard drive burns because it cannot physically handle that many concurrent connections on the same disk space. So that's actually a true story. There's this guy, there's a link who explains, oh, I tried to be clever with my file system and my thread pools, and it didn't turn out quite well. So don't try this at home. But the thing to remember here is that, so usually you have a pool of 4 threads, and that's good enough for your file system. All right, conclusion. So I just have to say something about Node. So yeah, Nginx uses that. Graphical clients uses event loops. Everybody's using event loops. But the special things about Node is that it's your language, right? It's your programming language. And if you take C and you try to do like file system stuff, you can't use the direct functions of file system because they're blocking. You need to wrap them yourself or call a library for this. But with Node, because the language didn't exist for file system at least. I mean, JavaScript exists, but you don't have file system calls natively in the V8 machine, right? So what Node did is they just created those wrapped file system calls, so you don't have to worry about it. Whenever you're going to do a file system call in Node, it's automatically going to be non-blocking, and you don't have the choice, so you can't make the mistake. So that's the quite clever thing with Node. That's it. By the way, if you're not aware of it, so it's not actually written. So for those who know, Node has been written in C++, right? But the event loop thing is actually not in Node, it's in an external library. So at first they were using libev, which is a replacement for libevent, but they found out that it wasn't good enough, so they created their own C library. It's written in C, it's called libuv. It's actually quite good. If you have a look at it, if you want to have a look at it, there's a link here that explains how it works, but it's basically what I just said. So there's an event loop, and for the edge cases like file system, just create a thread pool and everything. So my belief is that when you understand something, you get to use it in a more efficient way. So I hope this talk has helped you a bit about how Node works and how to use it more efficiently. I understand that it's quite a complex topic, and doing it on a talk is quite hard to follow. But I can give you the slides afterwards, and I also have the transcript as an article. So if you want to just read it and go through the code and everything, just give me a shot.